But I want you to, we're going to come back and look at B. All right. If you look over there on the board, I put this little sentence stem that Mr. Ackerman gave me that is kind of what you want to make sure you fill in on everything. And I realized when I was doing this, on the other questions that we hadn't gotten to yet, I didn't leave this off. I did leave it off on this one. But so what's in blue over here is required words. They never change. So if you kind of have a sentence stem that you know how to fill in the blanks, you can make sure you don't miss things. The stuff that's in pink is where you have to fill in stuff, just information from the problem. And then the purple is optional. It depends on whether we're approximating or not. Okay, so let's check that. And it doesn't have to, it's not like it has to be exactly that. But if you do it in that form every single time, it's just kind of, the consistency is important here. So when we look back here at B, okay, we pretty much did that, all right? So at, and it says the time instant with unit, so at t equals 15 hours, not just t equals 15, right? The, and I didn't put the, but so, and I probably would have reworded this had I used the word the there, which might have been helpful. I wouldn't have had to say it as much. The water flowing into the tank, the water's flowing into the tank. Then it says, is increasing or decreasing? I didn't put that here. Now the water, so it's really, the water is flowing into the tank at this rate, but had we said, and I don't want to make you necessarily rewrite it, but had I said the water, so I'm going to kind of write it on top of it, the water in the tank, okay, so the water in the tank, that's my first blank there, and then is the water in the tank increasing or decreasing? Increasing. Is increasing at, and then gone over here, an approximate rate of, or at a rate of approximately. Either way, I'm saying the same thing, but I just wanted to kind of revisit this one because the most important thing, however it's worded, what I missed here was that whole concept of increasing, because the increasing, decreasing, that's kind of like become like a big deal for us. But on the other ones that we do, we'll kind of write it using that little skeleton, and you'll see how everything kind of fits in there nicely, and you can make sure you have all the pieces. Because that's, I think, the biggest challenge on this sometimes is knowing what to say, how much to say. Am I saying too much? Am I not saying enough? You know, what do they want me to say? That sort of thing. Okay? We're all good on that one? All right, I think that'll make a little bit more sense when we go through the others. We finished all through D on this, right? Okay. So let's flip this over then, if you're done writing, and then we'll do number 2. Okay. So it is important that we actually start by reading what this says. You can't just ignore that part of it, right? So a turkey is taken from an oven and placed on a counter to cool. The table shows the temperature of the turkey at various times over a 3-hour period. So it's important to take into, put into your brain here, we've got time and we've got temperature. Our time is in minutes, our temperature is in degrees Fahrenheit, so that we can kind of make sure that that's on the front part of our brain here. So it says, use the data in the table to find an approximation for T prime of 75. So T 75 would go right here. If I want T prime, which is the derivative, that means I want the rate, right? The rate at which the temperature is changing at 75 minutes. So what do I have to do here? Slope. And it says approximation, so that kind of tells you you're not going to get exactly what you want here. We're going to have to just say that T prime, and I feel like there's not enough room here either. So T prime of 75 equals, and then we use the information on either side of where 75 would be, right? So this is going to be T of 90 minus T of 60 over 90 minus 60. So this will give me 110 minus 150 over 30. 150? Where did I get 150? Oh, dang it, 130. Jesus, I can't even pull the right numbers off the freaking chart. 130, yes, 130, I'm sorry. So then this gives me negative 20 over 30, which is negative 2/3 degrees. Oh, not degrees Fahrenheit, I'm sorry. It is a rate, right? So that is degrees per minute. So degrees Fahrenheit per minute. I almost just put degrees Fahrenheit. Degrees Fahrenheit per minute. Okay. Everybody okay with where everything came from? Okay, so now we're going to use that to explain ourselves. So we say at what? T equals 75 minutes, right? So I need the 75 and I need the units because it says time instance with unit. What are we talking about here? Temperature of the turkey. Temperature of the turkey. Okay. Is decreasing. How do we know it's decreasing? Because it's negative. Is decreasing at a rate of, do I need approximately here? Yes, I do. Two things here. It's an approximation plus right here. Come back and look at right here. I was supposed to do that and I didn't. I did it last time too, I think. Because it's approximately. It's not exactly that we're approximating. A rate of approximately 2/3 degrees Fahrenheit per minute. How come you don't have to? Because it's decreasing. The negative is what tells me it's decreasing. If it's decreasing at a negative rate, then it's actually increasing. Does that make sense to you? Okay. Yeah. So the rate is 2/3. The negative tells me that it's decreasing. So we're decreasing at a rate of 2/3, or changing at a rate of negative 2/3. So once you put this word decreasing in there, that takes care of the negative. If I just said changing at a rate of, then it would be the negative 2/3. Do you see the difference there? Oh, I did the wrong color. Hang on, I was trying to be consistent here. So this is my answer. I know y'all aren't color coding yours, but I was trying to color code mine right. 2/3 degrees Fahrenheit per minute. I'm sure they did. They probably didn't take them. Yep, we're about to start doing that like this week too. Probably tomorrow, next day. All right, we all good with that? Not till December. All right, then B. What is the average rate of change of the temperature of the turkey during the 3-hour period? Okay, so average rate of change, that tells you slope. That also tells you it's just straight up slope because it's average and not instantaneous, right? 3-hour period, so that's over the whole thing. So that means that I want T of 180 minus T of 0 over 180 minus 0. Okay? So this gives me 79 minus 185 over 180. Non-calculator question. And we could leave it here as degrees Fahrenheit per minute. So that could be a safe stop, but we really should be able to actually finish this. So this would be negative 106 over 180, right? And then we can leave that and not have to reduce the fraction, and that's fine. But it is better to actually subtract these because then you can see that it is the average rate of change is negative, so it's decreasing like over the whole thing. Okay? We good with that? What questions do you have? Anything? Okay. All right, so there must be a time t when the temperature of the turkey is 125 degrees. What do you think? Yes, and it would fall like right here-ish, between those two. So the answer is yes. So must there be, I'm sorry, go ahead. Did I do it wrong again? Good Lord. 125. Jesus, yes. My Lord, I don't know what is wrong with me today. Yes, thank you. It's between 60 and 90. Does not fall. But the good news is I wasn't going to be that specific when I did it, so it was fine if I'd have just completed that. But yes, thank you. Because sometimes I do need to narrow it down between these two, but it's asking over the whole thing, so that's good. I can just leave it pretty general. So if I'm going to say that, how do we know this? By what? IVT. If I'm going to use IVT, what do I have to say? Cat. I have to say that it's continuous, right? So is this continuous? Does it say that it's continuous? No. Does it say that it's differentiable? Then how do I know it's continuous? What is it that we're talking about?
The turkey.
What about the turkey? Yes, we're talking about the turkey. The temperature. Is temperature continuous?
Yeah.
Yes. So they don't have to tell us, since we know what the context is, temperature is continuous. It's not going to jump from one to the other. So we can say, since temperature is continuous, and 125 degrees. Now we can do it with the little like this, like we did before, which is fine, okay? But I'm going to just write it a different way so you can see. We can say 125 degrees is between, what are our degrees? 79 and 185? Yes? Okay. Is between 79 degrees and 125 degrees. There must be a time t on, or I could say on or for, t for, I'm just using the words. What? Oh my God, y'all. Oh, right here. Between 79 and 185, I was trying to get either side. Good Lord, I know, but I don't want to confuse you along the way because I'm doing stupid things. Unfortunately, all right, safe space, thanks. Yes, I know, it's recorded forever, it's fine. This isn't even my worst video I've ever made, so I'm good. Oh, I don't even know. I don't want to know. For a time t, I probably don't even realize that it is the worst video, whatever it is. For 0, okay. And what you want to be careful of, because I know I saw at least one of you, maybe more when we had done these earlier, make sure that you're putting time with time and the temperature with the temperature, you know, getting that in there. There must be a time t for where, okay, when the temperature of the turkey is 125 degrees Fahrenheit by what? IVT. Intermediate value theorem. So it's the intermediate, it's in between, kind of. You can kind of think of it as, nobody's ever probably going to ask you to write out what it means. So it means intermediate value theorem, but you can kind of think of it as the in-between value theorem, because that's really what it means, and that's how you're using it. So that helps you kind of keep track of it. Are we good? Any questions? Did I confuse anybody by my stupidity there? Okay. All right, so let's look at this one. The table below shows the rate at which a chemical is being pumped into a storage tank at a petroleum holding facility. Okay, so definitely like a real-world application problem here. So it says, so we have T in minutes. Now look at this, T in minutes, and we have a rate in gallons per minute. So it's not just time and amount, it's a rate and time, which really doesn't change what we do, but it does kind of change a couple of things you have to say, so we have to be careful. So we're going to approximate the value of r prime of 17. We can totally do that if I can figure out where 17 goes. It goes right here. Okay. All right, so that means that r prime of 17, my board's being ridiculous today too, r prime of 17, and then squiggly equal signs, because it means about, is about equal to. Let's see, we're going to do r of 24 minus r of 14 over 30 minus 25. Huh? No, yes, no, 10. Oh my Lord. 24, you see, you got to pay extra attention. Maybe this is helpful to you, right? You got to pay attention and ask if what I'm saying makes any sense at all. I can't even do slope. All right, I got this. I got this. I can do this. All right, 30 minus 25 over 10. I'm afraid to even subtract. Which makes it, yeah, thank you. I just jump up before I do something stupid. So this is 1/2, but then my units. It's gallons per minute is in the numerator. So gallons per minute over what? Minutes. It is not, because the gallon, no. Because what's happening here, look at this. This is gallons per minute over minutes, right? So the minutes is like over 1. So this is actually gallons per minute times 1 over minutes. So it would be really gallons per minute squared. Be careful not to try and cancel things out. It is gallon per minute squared. Y'all remember doing some stuff like that in physics? Okay. But we don't want to write it like that. We want to leave it as gallons per minute per minute. Okay? We're going to leave it like that. That's how you read it. Okay. So gallons per minute per minute. Do you understand where the units came from? You pull them straight from here. Okay? So that if it gets weird and confusing, you just write down whatever it is. Don't worry about trying to cancel them out, because you might get yourself confused on things. Okay? All right. So now we're going to explain ourselves using this. And our time instant is t equals 17 minutes. Okay, at t equals 17 minutes, d, and then we talk about what this is, the rate, right? So it is the rate of the chemical, so rate of chemical being pumped. Wait, rate of chemical, yeah, being pumped into the tank. I'm just going to say into tank, okay? So it's the rate of chemical being pumped into the tank. Is it increasing or decreasing? It's increasing because it's positive, right? So it's a slow rate. So it's 1/2 gallons per minute. So it's small, but it is increasing. So it is increasing. Increasing. The negative is what makes it decreasing. So it is increasing at a rate of. Yes. Well, I put it for, you can say is increasing approximately at a rate of, or at a rate of approximately is probably a better way to say it. I mean, as long as you're saying the right things, it's of approximately, and then my answer is 1/2 gallons per minute per minute. Gallons per minute is what it is. All right, we good on that? All right. Now, based on the values in the table, what is the smallest number of instances at which the rate the chemical is being pumped into the tank could be 20 gallons per minute on this open interval? So the open interval from 0 to 60, so we're looking at the entire thing. The minimum number of instances where it could be 20 gallons per minute. What do you think, and how do you think we figure that out? IVT, okay? So, continuous, okay, but hang on, because this is a little bit different. It's not saying, is there an instant? It says, what is the smallest number of instances, which implies there could be more than one, right? So looking at that table, how many instances do you think you could say for sure have to happen when it's 20 gallons per minute?
32.
I see 2, right? So we're going from 18 to 25, so 20 has to fall between there. And then 25 to 30, 30 to 21, 21 to 15, 20 also has to fall between there. Now, is there possible there could be more?
Yes.
Yes, because we just have these random times, right? It's possible that it went down below 20 here and then came back up to 21 for all we know. We don't know. But it says the smallest number of instances. So the answer is 2. Okay? So the answer is 2, but we have to explain ourselves. So yes, because I'm using IVT, I have to say continuous. And here's where I got stuck on this one, right? You start with the answer is 2. Like the number 2. Yeah, so based on what is the smallest number of 2? So, I mean, you don't have to start with the number 2. You could say the rest and then say, therefore, there's 2. Like, you can flip it around. But because I have to say it's continuous, how do we know that the rate is continuous? It's kind of because it's time. It's because, yes, the time is always continuous, but we're looking at this. It's a rate in which it's being, your rate can't just, even if we like turn it off, it's going to trickle down. Like it's not just going to change from one to the other. So the rate is continuous either way, okay? So we can say, and here's how you say this, because this is, again, what stumped me. We can just say that R of t is continuous. So when I was asking Mr. Ackerman, I was like, but how? Why? How do I know? Why do we know? And it wasn't a great answer. But the answer is this, is that what it comes down to. If we have an application problem in calculus, and it's a real thing, it's continuous. So you don't really have to hunt for it. But you do need to say, if it says it's differentiable, that's how you know. If it's temperature, that's how you know. If you're not sure to say how you know, just say it is and move on, okay? So R of t is continuous, all right? And then we can say that 20 is between 18 and 25 for t being between 0 and 14, right? T being, yes. And 20 is between 21 and 15. For 33 to 47. 33. Okay. So 2, therefore, I know, therefore, we already said 2. Well, we don't have to say. So we could say all this and then say therefore if we didn't say 2 here. We could say therefore there are at least 2 instances when the rate is 20 gallons per minute on 0 to 60 by IVT. So you got to be careful on that one, not just to say by IVT. You got to show the whole betweenness. So basically I had to do it twice instead of just once, since it wasn't asking me, is there one? It's asking me how many. But there, again, there could be more. That's why we use the words like at least, and this is the minimum number. Okay. What questions you got? Okay, so grab your assignment. I'm going to have you mark off a few of these. Because I'll be honest with you, I didn't get the key done before I gave it to you yesterday, and I was working on it today, and I was like, wait a minute, we didn't do these things. Okay, so I want you to mark off 1B, 2B, 4B, because those are all inverses that we didn't do yet. No, do 3B. But so 1, 2, and 4, mark off the B's. And then I want you to put stars next to 3D and 5C. Okay? 3D and 5C, those are kind of the challenge problems. So if you can do everything that isn't marked out, except for those star problems confidently, then you're good. And then those are the challenge ones, and we'll talk about them if we have to, but it's going to kind of push you past, what we're just talking about right now. Okay? Oh, don't freak out before you get there. Okay. All right, we good? Any questions? Okay, so, and it says, do